Hi everybody, my name is Cameron and today we're going to be looking at energy as a resource. We're going to be looking at the demands for energy and how those demands are met in different ways, as well as some issues that we face when it comes to energy demands and supply. So we all need electricity or energy. Okay, this is an energy demand, a demand for energy and electricity. Now, how we get this energy is from something we call a municipality. Different names in different countries for it, but basically it's your local government that is going to provide you electricity through a national grid system. This national grid system is going to take energy from the source, okay, be that coal power plants or nuclear power plants or wind turbines, and through something called the national grid, it's going to deliver it to your house in a form that is perfect for your wall plug. We'll get into more details about that now. Now, in the previous lecture, we talked about the fact that a lot of the times we will lose power or energy. Okay, we're going to lose energy to the environment. Okay, now when we have a power station, it outputs a large amounts of electricity. Okay, now that electricity needs to be transported from the power station to your house. This can be over kilometers and kilometers and kilometers. And you must have seen outside your window on your drives or something like that, these power lines. Okay. Now, to lose as little energy as possible, to keep those electrons moving through those thick power lines that have a lot of resistance, as well as the fact that sometimes they get very hot, that will also add to the resistance of the electric flow, we're going to use something called a step-up transformer. Okay, now step-up transformers are going to increase the voltage and decrease the current. This is going to give it enough push to get those electrons through the power lines and to the suburbs. Now, we can't have this super high voltage power line in our house, okay? Because if someone sticks a fork in it or some wires cross, it's going to create a huge explosion or kill people. So we're going to then use something called a step-down transformer. Step-down transformer does the opposite, okay? It's going to decrease the voltage and increase the current, thus making it usable for your lamp, okay, or to charge your cell phone. Whereas if you had to hook your cell phone up to a power line, it would probably blow up. So let's talk about where we get this energy from. Okay, so historically it came from something we know as non-renewable resources, okay, or non-renewable sources that use stuff like fossil fuels, oil, natural gas. Okay, those are ways that we burnt them and that would then heat up water that would turn a turbine and generate electricity. Okay, we call that non-renewable because eventually all the coal is going to run out, all the oil is going to run out, and so are the natural gases, and then it's not going to be replenished for another couple thousands and thousands of years. Okay, because that's how long it takes for these natural resources to be made. So, modern day, we look at renewable sources. These are sources that will not run out. Okay, sources like solar, wind, tidal, geothermal, nuclear. Okay. And a lot of the time, these renewable resources can actually be a bit more beneficial for the environment, or not beneficial, but just not harm the environment as much as the non-renewable resources do. So when we look at some of these renewable resources, one of them is biofuels. That's a lot of writing, but I'll just summarize it for you. So biofuels come from living fuels, okay? And it's not that the fuel itself is living, but the fuel comes from living organisms, okay? So living organisms are going to eat food, ingest it, and produce feces. Okay, it can also be from food waste as well as vegetable waste and wood chips. Okay, and basically what's going to happen is it's going to ferment. It's going to create something called methane and other biogases that are flammable. Okay, these flammable gases can then be used to do the same thing that coal would. Okay, now the advantages of this is that it is renewable. As long as we have cows, as long as we have chickens, as long as we have pigs, we are going to be getting these biofuels from them. Okay, it's also something called carbon neutral. That means that it is not producing carbon dioxide into the atmosphere, which our burning of non-renewable resources do. Okay, because those animals are going to be taking in carbon from the atmosphere, lowering the carbon levels, and then the small amount of carbon that is given off is equal to the amount taken in. So it's not going to change the amount of carbon in the air. Okay. Okay. So the disadvantages, on the other hand, is that it's not as efficient. It doesn't burn as well as it would your coal or your oils. Okay. It's extremely smelly, quite pungent, the word they use, and it's not always environmentally friendly. Okay, because we can't rely off of livestock because livestock require land. That means there's going to be a lot of deforestation. Okay, a lot of that livestock does produce greenhouse gases like methane. Okay, so it's not always too environmentally friendly, but it is a renewable way of getting energy. Another renewable resource that we talked about was nuclear energy. Now, how nuclear energy works is we take something like uranium or plutonium, which are unstable atoms, and we shoot neutrons at them, and this causes them to split. Okay, this is called radioactive decay. We learn about this in chemistry if you want to go have a look at those videos. Okay, so once they split like that, it is going to release energy. Okay, and it releases a lot of energy. That's one of the advantages. It releases a lot more energy than it would your fossil fuels. Okay, that energy could turn into a bomb in the case of Chernobyl. Okay, or it could be harnessed by the water around it, the coolant that they use. That water is then going to be heated up and turned into steam. That steam is then going to turn a turbine and it's going to generate electricity. Okay, now some of the issues with this though is that it's dangerous. You have to dispose of radioactive waste properly, and this can sometimes be very expensive, or it can leak out into the environment if not done properly and cause widespread issues in the environment, leading to radioactive areas. Okay. One of the other resources is wind. Okay, wind is basically harnessed using these giant, basically fans. Okay, so these giant blades are going to be put up into the air, very high up. Okay, or they can be on land or it can be in the sea. Sometimes they have these sea turbines. Okay, and basically, as the wind turns the turbine, it's going to have these brakes in it, and these brakes are going to cause electricity or are going to cause a turbine to spin. Okay, and that is then going to generate electricity. Now, some of the disadvantages, people say it's an eyesore. Okay, so it's not nice to look at, which I guess. It also depends on the wind, which isn't always there or isn't always strong enough. Okay, but some good placing will deal with that, I'm sure. It can sometimes harm wildlife. Okay, there's reports of it, hurting a lot of flying birds and especially its big birds. Okay, but some of the advantages, it's endless. Okay, there will always be wind. It releases minimal greenhouse gases, and it's also very cheap to maintain. Okay. Another one which is really interesting is your wave power. Okay, so this is something that is completely renewable. There will always be waves, regardless of the weather, regardless of the season, there are going to be waves. Okay, so basically how they work is you're going to have a buoy. A buoy is like a big inflatable ball. Okay, it sits on top of the waves. And as the waves go, this buoy is going to move up and down with the crashing waves. Okay, this is also far out to sea. So as the waves and the swells go, this buoy is going to be on a piston, and that piston is going to then generate electricity as the buoy goes up and down. Okay, now the issue is if there's a big storm, that fixed piston could snap or break off. Okay, it apparently also affects the environment negatively. If the buoy were to break, let's say, and pieces were to get into the ocean. But some of the advantages are that there's zero greenhouse gases to this. Okay, it's renewable and does not need much land. Okay, you literally just put it in the ocean. which is vast. Okay. Hydroelectric power. Okay. You might think, but hydro, it means water. Okay, which you're not wrong. But this uses the movement of water rather. Okay. So how this works is you're going to have very large towers. Okay, and these towers are going to collect rainwater. Sometimes it can be on the top of a mountain, let's say. Dams use this a lot. Okay, and basically, as you let out the water, that water is going to be pushed through the hole through gravity. Okay, and as it's being pushed through the hole, it's going to be spinning a turbine, and that turbine is then going to generate electricity. Now, some of the disadvantages of this is that if there's no rain or if the dams are low, then you're not going to be able to generate electricity. Okay, it also destroys habitats. Okay, dams can completely, or they completely flood areas. Okay, um, and they require lots of space. Okay, a dam wall is huge. These towers are massive, and what's going to happen if they're not maintained? Then those turbines are going to break. Okay, and you're not going to be able to release this water and gain electricity from it. So it's quite a complex task, even though it's a simple concept. But some of the advantages: zero greenhouse gases, and none of the energy goes to waste. Okay, any excess energy is used to pump that water back up to the tower or back up the hill or wherever the reservoir is. Finally, we're going to look at probably the most well-known renewable resource, and that is solar power. Okay, so as we all know, we're going to use solar cells or solar panels to. It's one of the ways, one of the ways that we can harness solar energy or solar radiation. Okay, if you remember, we talked about infrared. Okay, so how these solar panels work is they are going to be absorbing the energy from the sun and converting it into electricity. Now, the issue is that it converts less than 10% of that solar energy into electricity. So they're kind of inefficient at the moment. They are developing better and better solar panels every year, though. Okay. But they're very cheap to maintain compared to other forms of renewable energy. I mean, that's why we have them in our house, right? I can't erect a wind turbine in my house, and we can't just put buoys in the pond, right? But solar panels are probably the cheapest form of this renewable electricity or renewable resources. Okay. You do, however, need quite a lot of them to power a house. Let's say your whole roof needs to be covered with them to power your entire house, and then it might be cloudy, or it could be dusty, or they could get dirty. Let's say, and then the efficiency will drop significantly. Okay. Other ways of harnessing the sun's energy, though, is something called solar powered towers. Now, these are really cool. I've driven out into the desert before, and it basically looks like a sun on Earth. Now, if you look at this picture here, you'll see that these, they look like solar panels, aren't actually solar panels. They are mirrors, and those mirrors are surrounding a tower. Okay, and basically those mirrors are going to be directing the sunlight at one point in that tower. Okay, and in that tower there is salt. That salt is going to get incredibly hot because salt has a very, very high melting point, thousands and thousands of degrees. Okay, we can then harness that heat from that salt, okay, to generate electricity. We also have solar heating. Okay, a lot of places use solar geysers. Okay, so the geyser will get its warm water from the sun rather from heating it with electricity from the international grid. Okay. So as we can see by this, there are many different ways of generating energy. Unfortunately, renewable energy is only 19% of the total amount. We are still heavily reliant on our fossil fuels, so our petroleum, coal, and natural gases. Okay, we use a tiny bit of nuclear energy, but you can see here that the renewable resources or the renewable sources of energy are vast. There's quite a few of them. Okay, so we just need to put more money more research into making these a bit more feasible and a bit more accessible to countries and the everyday person. And then we'll be well on our way to having a fully renewable energy world, okay, which will then decrease our global emissions of greenhouse gases and hopefully create a healthier planet. So, as we've mentioned, some of the issues with renewable energies is that there can be other side effects, okay, such as nuclear waste. It can be damaging to the environment around it, okay. So, let's say like the wind turbines, like the um, wave power, okay. But as we said, it's a never-ending supply. Okay, they're not going to run out. They don't create greenhouse emissions. It can also work on a small scale. Okay, so the amount of electricity generated by one wind turbine would need a factory, a transport system for a coal power station to work. And it was in the COP28 summit in Dubai last year that the United Arab Emirates concluded with the first ever pledge to phase down their fossil fuel use. Okay, other countries also pledged to increase or to triple their renewable energy by 2030. So on the right path, we just need to keep it up. So using more renewable resources to generate our electricity and cutting down on our greenhouse gases. Okay, and to you, the viewer, the listener, what you can do is conserve your electricity, buy energy saving light bulbs, use less electricity, and we'll be fine. My name's Cameron, and I'll see you next time.